Here we have two combination of the capacitors, which are connected in parallel and also in series. The capacitor consisting of two parallel plates of area A is given and spacing between them is D, is filled with two parallel slabs of dielectric material of equal thickness and with dielectric constant K1 and K2. What is the total capacitance? Now in the first case, as you can see here, we have capacitor was filled with two different dielectric which has same thickness, and the thickness of each one is d over 2. Okay, now as you can see here, they are connected in series, so therefore you have to find in the problem equivalent capacitance. Okay, so equivalent capacitance is basically when the capacitors are connected in series, it will be C1 times C2 divided C1 plus C2. Now C1 is equal to what? Now the C1 is equal to the K1 epsilon naught. Area is the same, so we just have one area, divided by the distance. Distance in our case is the distance or the thickness of the first dielectric K1 will be d over 2. Now if you plug the numbers, you should get C1. For the C2 will be K2 epsilon naught area and divided by the d over 2. Now you can find separately C1 and C2, and then you can just plug them here to find what is the C equivalent capacitance. In the second case, we can see that the area is divided by the 2 equally, and we have again same dielectric constant, but however diameter is just a d here. So as you can see here, both of them are connected in parallel. Then you have to find equivalent capacitance where they're connected in parallel. So C equivalent or C in parallel is equal C1 plus C2. Okay, now the C1 here is equal K1 epsilon naught. Now the area is the half of it, right? So area over 2 divided by the d distance. Okay, for the C2 is equal K2 epsilon naught, again area is half divided by a d. Now then you have to find both of them, and then you can just plug it here to find equivalent capacitance.